Hi, those who are here. Are you able to scan the QR code to access the materials? If you can, just give me a thumbs up so that at least I know. J- Oh, great. Okay, so yeah. We will start from around 5 plus. Okay, in the meantime, just chillax. Hi everyone. Yeah, we're gonna start at around 5:05. In the meantime, you can scan the QR code for the notes itself. If you look at the notes, so if you look at the notes, primarily we will focus on three topics: reactivity series, periodic table, and rate of reaction. Hi, evening everyone. So we'll start at around 5:05. In the meantime, if you are looking for the lesson material, yeah, just scan the QR code. You will be able to download a copy of the lesson material. Yeah. Sorry, if anyone cannot access the lesson material, can you like type in the chat that so that at least I have an idea that you can't access? Yeah. Oh no, I'm starting at 5:05. Yeah. Evening everyone. You can access the lesson material by scanning the QR code. If you can't access the lesson material, just sound off in the chat. I will attend to you. Okay? Yeah, we'll start at about 5:05 because I think there are still people pouring in. Yeah. Hi. Sorry, give me a minute. Hi. Okay, hi, evening everyone. I'm more or less going to start. So so this is the Sec 4 Pure Chemistry WA1 Online Revision event. Primarily this event is going to focus on three topics. I know if you look at the brochure, it says only the first two, which is reactivity series and periodic table, but I will incorporate rate of reaction into these two topics as well. So technically it's a three topic revision program for today. To be completed in 1.5 hours. Okay, so before I go on, what I'll do is if you have not gotten the lesson material, please scan the QR code. This will disappear in about 5 seconds, but don't worry, before we start the class, I will flash out the QR code again for everyone to see. Okay. Everyone okay with the audio, right? Anyone who cannot hear me very clearly, please sound off now. Okay. Okay, wait, let me see. Able to send the link. Oh, okay. I think probably can give me a minute. Okay, if you really need the link to the lesson material, I put it in the group chat. Yeah. Okay. No worries. Okay, with that, let's begin. Now, throughout this whole process, if you feel like you have any questions you want to ask, please feel free to ask. You can unmute yourself to ask your questions, or you can type in the group chat. I will monitor the chat itself. And then if not, maybe some of you don't really know me, maybe you are new to Overmark. So let me just do a quick introduction to Overmark as well as to myself. Okay, so this is the WA1 Online Revision event. First of all, I'm Ashley. Please don't call me teacher, don't call me sir. I will not give the rate of reaction notes. It will be more of incorporating rate of reaction ideas into the question. So there's no rate of reaction notes. The notes is still going to focus on reactivity series and periodic table. It's just that because chemistry is quite integrated, so there is a potential for rate of reaction to come out as a linking question. So that is why I say I will still talk a little bit about rate of reaction. So unfortunately there's no notes on it. Sorry. So first thing is I'm Ashley. Don't need to call me teacher, don't need to call me sir lah. Too formal. So just call me Ashley will do. I teach chemistry, maths, and physics at secondary and JC level. In Overmark, my focus is primarily on Sec Chem and JC Chem. Yeah. So just some interesting facts about me. I graduated from Victoria. Before I started teaching at Overmark, I was actually a textbook editor. I think all of you are using Chemistry Matters. Am I correct? I edited the book, so I was an editor of the textbook itself before I left Marshall Cavendish. Okay. Yeah, so that's all about me. Yeah, don't need to be too formal with me lah. Just call me by my name. It's fine. Let me continue on. So at Overmark, technically there are 7 branches right now. And then distinction rate is about 70% every year at national exams. Then last but not least, the resources that we have. So what you have received today is 2 chapters of the curated notes as well as some weighted assessment revision worksheet that I have planned. Moving forward, obviously there are some mock exams as well as some practical experiments, hands-on experiments that we will conduct at the end of that means closer to your practical paper. So if you are interested, you may consider joining then. I think all of you are not here to listen to me talk about myself as well as talk about Overmark. I think what you are more focused on is the WA1 that's coming up. So this is technically what I will be covering today. So the agenda for today is I will be focusing on two topics, reactivity series and periodic table. I will do a content summary first, meaning that I will use the curated notes that I've given you, but I will kind of do up a summary in a one-page summary for you on these two chapters before we look at some commonly tested questions inside the revision worksheet. Okay. Then last but not least, I will do a debrief. That is where you can ask any questions and I'll answer you. Actually, technically, I know the session is supposed to end at 6:30, but I will stay back after 6:30 to answer any of your question. Obviously, because of the time limit, I can only focus on these two chapters, but I'm pretty sure some of you are being tested on other chapters, probably like energy changes, probably like rate of reaction, as well as probably like electrochemistry. So I will stay back after class to answer any of those questions. If you have anything you want to ask me about the WA1, just stay back after 6:30, I will answer you. Okay. So this is the final call for the revision materials. If you need access to the revision materials, please send the QR code. Alternatively, what I'm going to do right now is after this page is gone, I am going to put the Google Drive link inside the chat so that those who are late can access it. Okay. Okay. So technically that's what I will do. My advice to everyone is get ready some paper, get ready some pens, especially different color pens, because I will not talk about the notes at all. In fact, what I'll do is I'll take the whole 8.4 notes and just summarize it into one sheet of paper for you. So I think that is what I meant by content summary. Okay. Okay. If that's the case, let's not delay anymore. So let's get this class started. Okay. Yeah. So last call. Anyone need to scan? Quickly scan, or don't need to scan one, just refer to the Google chat link. Can? Okay. Okay. Okay, let's go. So okay, so as I go through the content summary, I will highlight to you what are certain reactions that you should focus on for metals or for reactivity series, as well as for periodic table. Okay. So please kind of take note. This is like really like you last minute, left 5 minutes, you need like a one-page summary because you haven't studied for your WA, then refer to this. Okay. So with that, let's start off with the summary of reactivity series. Okay. Okay. So in the reactivity series, what is important? Obviously, I think all of you know the most important thing that you need to remember is your reactivity series itself. So let's start off with that. So we need to recall our reactivity series. Now, I believe your teacher have taught you certain acronyms, certain methods of remembering. But in the event that maybe your teacher just say, memorize this, then end of story. Maybe what I'll share with you is an acronym that you can remember to remember your reactivity series. So how I remember it is I use the acronym pop singers can make all crazy zombies in town lose his cool, silly goose. Okay, now this was not the original acronym that I remember it by. Maybe I'll share with you guys an exam tip or a studying tip. So usually what happens is that you can remember things better if you relate it to your friends, you relate it to real life, make it very funny, make it very funny. So uh I I have a sister, her name is called Xing Quan. Xing Quan, my sister Xing Quan is considered quite pretty for her age lah, okay? But the boys, that means her boyfriend all a little bit weird. What do I mean? That means if you know my sister Xing Quan, right? Her boyfriend all like zombies like that. What do I mean? That means they're all like gamers. So you know, like gamers usually game until then late. Then what happened is like they all have very dark eye circles. So they really look like zombies. So when I was in secondary school and I was studying this topic, then I was like trying to remember the reactivity series. And then I was like looking at my sister and then looking at her boyfriend because they are like in front of me, right? Then I'm like thinking, how can I remember the reactivity series? So my original version of the reactivity series, the acronym was Pretty Xing Quan make all crazy zombie boys in town lose his cool silly goose. But obviously, Xing Quan is my sister. None of you know a Xing Quan, or maybe you do. But what I'm trying to tell you here is try to relate to your real life when you're trying to remember things. Okay, so after that, you know, when I started teaching, then obviously I cannot tell my sister, my students to go and remember my sister, because none of you know my sister. So what I told them was, all of you like pop stars, right? So you think of pop singers can make all crazy zombies in town lose his cool silly goose. So this is something for you to remember it by. Now, what does each acronym mean? So for P, it is for potassium. S is sodium. Calcium. Magnesium. Aluminium. Then we have carbon, zinc, iron, tin. Okay, so I think some of you, your reactivity series don't have tin, but tin is a good metal to put in. It's also a good metal for you to remember. Then lead, hydrogen, then copper, silver, gold. Okay, now if you look at this list, obviously you will be able to find these two suspicious characters: carbon, which is not a metal, and hydrogen, which is not a metal. But these two are there because it can help you to remember things. And I'm going to show you how to remember what type of metals react with what later in a minute. Um, Okay, now next. I think some of you who are more analytical, you are like thinking, okay, is there like another way I can remember the reactivity series? Yes. So perhaps what I want to do is to kind of explain to everyone what is the rationale of this reactivity series. Now, basically, obviously, the reactivity series is to arrange your metals. Am I correct? Now, when you look at a piece of metal, if you think about it, metals can only lose electrons. Metals never ever gain electrons because it would take too much energy to gain electrons. So they tend to lose electrons. When you lose electrons, you undergo something called oxidation, which most of you should have learned in redox. So what is the reactivity series all about? The reactivity series primarily, correct, is to is focusing on the ease. So it focuses on how easy it is for a metal to lose electrons. So the reactivity series is actually there to tell you how easy the metal can lose electrons or how easy the metal can undergo oxidation. So if you look at the top, the first two is group 1 metals. So obviously group 1 metals lose electrons very easily because they only have 1 electron, followed by group 2, correct? Because they have 2. Then after that, it's group 13 because they have 3. Then we take a break and we look at certain transition metals before looking at group 14, then transition metals. So this is also another way you can remember your reactivity series. You arrange it by groups. Group 1, group 2, group 3, then zinc, iron, group 14, then copper, silver, gold. Okay? So primarily we'll start off with the reactivity series first. Okay, around okay? Okay, next. Now, if you recall this topic, there is a lot of reactions. So how can you categorize this reaction? So how do we remember the reactions very well? I think it's important for you to understand what type of reactions are we dealing with. So primarily in the topic of reactivity series, you'll be dealing with 2 types of reactions. What are the 2 types of reaction? The first type of reaction that I'm going to write on the right-hand side are reactions of metals. That means there will be certain reactions that you learn in reactivity series that is concerning the metal only. Primarily, there are 4 reactions here that you need to remember. Then what happens is the remaining reactions that you need to learn are involving the metal compounds. So it's reactions of metal compounds. So there are only 2 reactions here. So if you are creating your notes now, right, what happened is write the reactivity series in the middle. On your right-hand side is reactions of metals. On your left-hand side is reactions of metal compounds. Okay, so primarily this topic, you need to remember 6 reactions. So we're going to now talk about these 6 reactions. How to remember? Very easy. Everyone here should know Blackpink Lisa, correct? She's from Thailand. So when you go to Thailand, usually what you need to do is you need to say the greeting, which is Sawadika. Using Sawadika, you can actually remember your reactivity series. How? Some of you are wondering how. So just remember this. Swadika. So when you think of reactivity series, think of Lisa from Blackpink saying Swadika to you. Okay? So remember Swadika. Okay, now let's talk about what Swadika is all about. Like, what is this thing? Okay, so I will put focus more on the right-hand side now, which is reactions of your metals. So based on what we know, metals can react with 4 different things. S is your steam. So metal plus steam, there will be a reaction. Okay. Next, which metal can react with steam? So if you are in Teacher Gerald class, Teacher Gerald will tell you, hey, you need to remember Mi, Mi, which is magnesium and iron. So to be honest with everyone, magnesium, iron, carbon, and hydrogen, these 4 elements are technically very important when it comes to reactivity series because these 4 elements can help you to recall the reactivity series itself. So for steam, who can react with steam? Remember Mi, the I, iron. So whatever that's above iron will be able to react with steam. Okay, I'm going to tidy up a little bit. So what happened is I'm going to remove this part. If not, the thing will look very complicated for you. So remember, iron and whatever that's above iron will be able to react with steam. Okay. Anyone can tell me when metal react with steam, what do you get? You don't need to say out loud. You can type out in the answer. Maybe I'll ask. Let's ask Peiwen. When you take metal and you react with steam, what do you get? You can just type out your answer for me. Yes, very good. Metal oxide. So when you take metal and you react with steam, it will give you metal oxide. How do you remember? Just think of SOX, SOX. So steam give you oxide. Thanks, Payman. Okay, so that covers the first one, steam. Next, number 2, water. Water. Yes, and hydrogen too. But most of these substances all produce hydrogen, if you think about it. Steam produce hydrogen, water will also give you hydrogen, acid will also give you hydrogen. Yeah. Okay, next. But more importantly is because why I focus on oxide is because most people will mix up steam and water, the products. So for W, when we have water, first thing first, which metals can react with water? You think of your magnesium. So whatever metal above magnesium will be able to react with water. YW, since you talk about hydrogen, right? Then I think you probably will know when metal react with water, what do you get? Hydrogen, yes. And besides hydrogen, hydroxide, yes. So that is why I focus more on the idea of metal oxides and metal hydroxide. So you must remember, steam will give you metal oxide, water will give you metal hydroxide. This is the part where a lot of students get mixed up. So they think that steam gives them hydroxide, water gives them oxide. No, steam gives you oxide. So you think of the acronym SOX, SOX. Water will give you hydroxide. So you think of HWO. Okay? Now, so basically that's it. Magnesium and metals above magnesium will react with water. And when they react with water, they will give you the metal hydroxide as well as H2 gas. Next, we'll move on to the third one, A. So with A, I think most of you know A is acid. So when you think of acid, you think of H plus ions, am I correct? And when you think of H plus ion, you look at the reactivity, you see hydrogen. So whichever that's above hydrogen will be able to react with acid. So how do you remember these 3 metals? You think of IMH. So remember IMH, iron, magnesium, hydrogen. These 3 are very important metals. So including hydrogen and everything above it. Yes. Mm. Now, like what YW was telling us, right? When all of these three substances, SW and A, react with metal, they will always give you hydrogen gas. So besides the oxide, they will give you H2 gas as well. Okay. So I hope everyone can understand. I hope this reactivity series, this chart itself is clear. Which metal can react with water, which metal can react with steam, which metal can react with acid. Okay, now, can someone tell me what do you think the D stands for? Okay, maybe let me choose my next victim. How about faith? So what do you think this D stands for? DK? You mean like DK from 17? Oh, don't know. Oh, sorry. uh, okay, how about Esther? Okay, I shall not drag this out lah. Okay, D is very important. So Faith, you must pay attention now. In reactivity series, this D is super important because D is your displacement. So the displacement reaction is very important is because the displacement reaction involves all the metals. So if you can see, I'm not going to draw an arrow here because it involves the whole reactivity series. Speaking of which, the reactivity series, the most reactive metal is potassium and the least reactive metal is gold. Okay, so what is this displacement reaction all about? I think most of you, when your teacher teach you displacement reaction, your teacher will tell you, okay, can you please memorize this? A more reactive metal displaces a less reactive metal from its salt. So your teacher will say, you chant this to yourself. A more reactive metal displaces a less reactive metal from its salt until you get it. But I'm not going to do that. What I'm going to do is I'm going to tell you how to tackle this part. So how do you tackle a displacement reaction? Because I can assure you for your WA1, if you are tested on reactivity series, the chances of displacement reaction coming out is almost as high as 90. It's almost as high as 99%. So confirm your teacher will test you on displacement reaction and you confirm need to know displacement reaction. SWA, this reaction is not as important as displacement reaction. So I'm going to spend a little bit of time talking about the displacement reaction. So instead of trying to keep chanting to yourself this until you get it, what I told some of my students is you do what I like to call as two checks and two balances. So what is this two checks, two balances? Okay, so first thing is step one, we are going to do a two check. So we are going to check the reaction, see whether the reaction can work or not. So in a displacement reaction, you are always given two substances. What are the two substances? You will be given a pure metal. And then what happens is you will add the pure metal to a salt. The salt will consist of a metal ion. So technically, you will have a reaction looking like this. The pure metal will be added to the salt, and the salt will contain the metal ion. And then what happens is they will see whether there's a reaction or not. Okay? Now, what do you need to check? Very simple. Your pure metal, you need to ensure that it's more reactive. So if you take the pure metal compared to the metal ion, your pure metal need to be more reactive and your metal ion need to be less reactive. If you do this check and this check clear, that means it's correct. That means there will be a reaction. Then you can proceed on to the two balances. So what is the two balances? The two balances will be this. The more reactive metal, right? What will happen to it? Originally, it was a pure metal. It will become a metal ion. For your less reactive metal, originally it was a metal ion. It will now become a pure metal. So basically, that is the whole idea. You do the two checks first. If the check is correct, then you can do the two balances. If the check failed, that means there's no reaction. So if this check passes, do your two balances. If the check fails, then no reaction. But I'm talking about it in a very general sense. So some of you may not get it. So let's do a quick example. Okay, example. Okay, we will start with this reaction. Copper, no, not copper. Zinc reacting with copper 2 sulfate. Okay, I want all of you to go and think about it. Can this reaction work or not? Okay, 5 minutes. And then if the reaction can work, write out the chemical equation for it. Not 5 minutes, 5 minutes too long. 2 minutes, 2 to 3 minutes. Okay. So everyone on your paper, think about it. Zinc reacting with copper 2 sulfate. Can this reaction work? Hey, don't need to tell me the answer. Okay, come, Victoria, what does SOX means? SOX means steam will give you metal oxide. So S is steam, OX is oxide. Who is W, which is water, will give you hydroxide. So HO is hydroxide. Okay. Johnny, thanks for telling everyone the answer. So obviously, Johnny figured out that the reaction can work, but let me show you how you can do these two checks and two balances, okay? So if you can see, zinc is the pure metal. Copper, this is copper 2 plus. So copper 2 plus is the metal ion. So we check first. Okay, so zinc compared to copper, zinc is more reactive. So this thing is more reactive. And copper is less reactive. So if you do the check, yes, the check works. This reaction can happen. Then what will happen? The zinc from a pure metal will form zinc 2 plus. You must remember, zinc can only form a +2 charge. So you don't have to stress, even though it is in the transition metal block, zinc only forms a +2 charge. So zinc 2 plus, SO4 2 minus, you form zinc sulfate. Your copper 2 plus from the metal ion will become a pure metal, so it forms copper. So this reaction can work. You done the two checks, you did the two balancing. Okay, so if you can see, the pure metal become a metal ion. The metal ion become a pure metal. Okay. Okay, so this is the foundation. This is the fundamental concept. Now what I'm going to explain to you is what are the different exam questions that could come out for exam. Correct? I think all of you want to know more about what could the teacher ask me for WA1. Primarily for displacement reaction, they will only ask you 3 exam questions. 3 possible exam questions. Either these 3 will come out or 1 to 2 questions will come out. The first type of question that they will love to ask is, why this reaction can work. Okay, so the first possible question that they will come out is why there's a reaction. So they will say something like, state whether there's a reaction and explain why there is a reaction. So why is there a reaction? And this is where you need a little bit of your answering technique. So what you need to tell me is zinc being more reactive than copper displaces copper 2 plus from copper 2 sulfate. Now take note, when you are talking about the two metals, one being more reactive than the other, use the element. Don't talk about it like, don't talk about the ions, talk about the element. So zinc element being more reactive than copper element will displace, then you talk about the metal ion being displaced from the actual reagent or the actual reactant. That should be how you explain this. Now, if you kiasu kiasi, like you want like write extra, you think okay, safer, then basically it's tell me what you will form. So zinc being more reactive than copper will displace copper 2 plus from copper 2 sulfate to form zinc sulfate and copper. So if you want to play safe, then you talk about the products as well. So the first possible question they're going to ask you is why the reaction can work. Okay, next, what is the second possible question? Second possible question that they're going to ask you is to state the observations. So they'll ask you to tell me what you will observe when there's a reaction. Okay, when you want to talk about observations, primarily we always approach it through four things. That means we'll talk about roughly about four things. The first one is whether there's any effervescence of gas. Clearly, this is not very relevant to the displacement reaction, so we don't need to talk about this. Number two, you will talk about dissolution / formation of solids. So meaning that did any solids dissolve? Did any new solids form? This one obviously is quite relevant because if you think about it, the gray zinc solid will dissolve and then the reddish brown copper metal will be formed. So this is basically what you're gonna need to cover. Third, any changes in the color of the solution. So this is also quite important. This is also quite relevant because if you think about it, copper 2 plus or copper 2 sulfate, this is blue in color. After the reaction, when you form zinc sulfate, it's going to give you white in color. Mr means more reactive, Lr means less reactive. Okay, so point number 3 is relevant because copper 2 sulfate, this is blue in color. Then after the reaction, when you form zinc sulfate, you form a colorless solution. So you need to tell me what the color change. Okay, final point number 4. So when we talk about observation, usually we need to focus on these 4 observations. The fourth observation you need to focus on is temperature change. But unfortunately, temperature change is not very relevant when it comes to theory paper. So unless you are doing practical, then you will focus on temperature change. I can be honest with you, if you did this reaction in the lab, you go and touch your test tube, you will feel hot. So there is a temperature change, but temperature change for this question is not relevant. So in theory paper, not relevant. Focus, when you talk about temperature change, it's more for practical paper. So it's more for practical. So with that, let's take a look at how can we answer the observation with regards to this experiment. So if you see this experiment, the solids got changed color. Zinc is a gray solid, so you will tell me the gray solid dissolves. Or oh, okay, you cannot see. Okay, I zoom in. Can? Naya, okay now. Good. Okay, so what you will see is, if you see the gray metal zinc will dissolve. So the gray solid dissolves. And you form copper 2 metal. So a reddish brown or pinkish solid is formed. Okay. Now, some of you might be wondering, copper is reddish brown. Why you talk about pinkish? Okay, so this is the thing about copper. Copper, if you see it without any water, that means it's not inside water, it's reddish brown. But if you have very pure copper and you put it inside water, it will appear as pink. Okay, so these two answers are acceptable in at O levels. When you form copper metal, you can say that you form a reddish brown solid or you form a pinkish solid, but that's provided that the solid, the copper metal, is inside water. So if it's not inside water, it should be reddish brown. But if it's inside water, you want to say it's pinkish, you want to say it's reddish brown, Cambridge will accept both answers. So that is your first observation. In terms of solid, that's what you will see. Next, in terms of solution. So in terms of solution, what you will see is the blue solution decolorize. Or turns colorless. So copper 2 sulfate is blue, zinc sulfate is colorless, so blue turn to colorless. Now, what do you observe in terms of answering technique here is that when you want to talk about observations, especially for color change, please always do this, which is that you tell me the initial color plus the state. And then what is the final color plus the state? This is the type of answering technique that your teacher will be looking for. So you don't just tell me it forms a blue solution, thinking that you will, or it forms a colorless solution, thinking that you will get the mark. No, you must tell me it changes from what color in what kind of state to what color in what kind of state. Why is the precipitate not blue? PPT blue is copper 2 hydroxide, my dear. So copper 2 hydroxide then is blue. Here we are talking about copper metal, so it has to be reddish brown or pink. Chloe, we are talking about different substances here. Understand? So if you are talking about precipitate being blue, you are talking about copper 2 hydroxide. You are talking about QA. You are not talking about reactivity series here. Is that clear? Okay, good. So take note of this answering technique because it's going to be useful for not just in theory paper, but in practical. When you want to talk about solids changing color, solutions changing color, always tell me the initial color and the initial state, and then the final color and the final state. Okay, I need these two things. Now, the final question that they're going to ask you is, why is there a reaction, right? And then the final question that they're going to ask you is, why is this reaction a redox reaction? So why is this reaction a redox reaction? It's very clear cut. I think most of you need to go back and recap your redox. So if you think back, zinc, this is 0 oxidation state, correct? And then copper metal, also 0 oxidation state. But when you're dealing with the ion like copper 2 plus and zinc 2 plus, the oxidation state is a +2 and a +2. So as you can see, zinc went from 0 to +2. This is oxidation. And copper went from +2 to 0. So that is a reduction. Okay. Okay, let me explain a little bit. Hashiga. But my teacher said that copper solid is only pink, iron 3 is reddish brown. Your teacher is not wrong. So usually what happens is copper metal is pinkish if it's very pure. But I think I'm coming from a standpoint of practical. If you do practical, you rarely will see pinkish solid. You will see reddish brown solid. So as a result, Cambridge allows for both. But I think in theory paper, if you want to play safe, they just say it's pinkish lah. Okay. Then yes, iron 3 PPT is reddish brown. That is confirmed. Hashiga, okay now. Yeah, I hope I cleared that. Okay, so basically that's how you explain lah. So basically you just tell me zinc undergoes oxidation because zinc, the oxidation state of zinc went from 0 to +2, and then copper 2 sulfate undergoes reduction because the oxidation state went from +2 to 0. I think some of you are looking for a little bit of the answering technique. So let me just share with you how I will answer question number 3. So usually what we will do is you remember this thing, RERP. What is RERP? So you tell me the reagent, the reactant first. So for example, zinc undergoes oxidation as the oxidation state of zinc increases from 0 in zinc to +2 in zinc sulfate. So if you can see, this is the reactant, this is the element, this is the number in the reactant, and this is the number in the product. Same thing, copper 2 sulfate undergoes reduction as the oxidation state of copper decreases from +2 in copper 2 sulfate to 0 in copper. So same thing, RERP, reactant, element, the number in the reactant, and then the number in the product. Okay, so that is your answering technique, and that covers the displacement reaction. I think I scroll up here. Okay. So this is your displacement reaction, and this is technically what these are the type of exam questions you will expect your teacher to set for your WA1 when they are talking about displacement reaction. So usually they'll ask you why is there a reaction, and then what is the observations, and then why this is a redox. Sometimes they might throw in a little bit of stoichiometry. If not, then technically more or less that's it. Okay, I'm done. So I'm done with the reactions of metal, okay, which is on the right-hand side. Now I will move on to the reactions of metal compounds, okay, which is on the left-hand side. So here we are talking about not pure metals, but we are talking about compounds of metals. Now, so first thing first, you need to understand the underlying foundation involving metal compounds. So for metal compounds, it's very simple. You just need to remember this. The more reactive the metal, the more stable the compound. So the more reactive the metal, the more stable the metal compound. So if your compound is very stable, if you want to do any reaction, it is less likely to happen. So the less likely or the harder the compound will react. So metal compounds in general will do two kinds of reaction. The first one, DC, is for decomposition. So your metal compounds can do decomposition reaction, which basically, what is decomposition? So you heat it up, you heat the compound up and the compound break down. I said. So the idea is more reactive the metal, more stable the compound, harder for the compound to decompose, harder for the compound to break down. Okay? So basically, that's the general idea here. The more reactive the metal, the more stable the metal compound, the less likely or the harder the compound will decompose. Okay, now, there are two reactions you need to learn. Oh no, primarily one reaction you need to learn. The other one I just share with you as a form of enrichment. Okay, so what do I mean? Okay, so when we do decomposition reaction, this first reaction is in syllabus. This one is the confirmed guarantee chop you must remember, which is if you take a metal carbonate and you heat it up, it is going to break down to give you metal oxide plus CO2 gas. So this one guarantee chop, you must remember. Metal carbonate, if it decomposes, will give you metal oxide plus CO2 gas. Okay? Now, if you think about what I told you just now, more reactive metal, more stable compound, harder to decompose. Which group of metals do you think will not decompose at all? Let's see, who can I ask? How about Joven? So which group do you think cannot decompose? Because the compound is super stable. Off to Joven. Okay, if not, then how about Hashiga? How about you? If you don't mind. Which group do you think is very stable, cannot decompose? Is it group 18? No. Group 18 will not even form compounds, right? Because group 18 noble gases already got full shell, so will not form compound. Yeah. Thanks, YW, very good. Thanks. It's group 1 metals. Because why? If you recall, group 1 metals are your most reactive metal, which means that the compounds that group 1 metal form are the most stable. If you try to burn it, it will not break down. So in terms of practical, okay, what happened is that if let's say I give you a piece of solid, I give you like a white solid, I ask you to heat it up, okay? technically, if it was a group 1 metal carbonate, or technically if it was a metal carbonate, if you heat it up, you will be able to test for CO2 gas. But for if it was a group 1 metal carbonate, you heat, you heat until you die, the group 1 metal carbonate will still be there. It will not decompose. So what happened is, the idea here is, take note, group 1 metals do not decompose. So they do not decompose, which means that you will never be able to test for a CO2 gas. You heat up the group 1 metal until the end of time, it is still there. Okay, so the first reaction, this metal carbonate, is something that you need to know. The second reaction that I'm going to share with everyone, okay, this one is more of like, don't need to know, but O levels love to test in practical. So what happened is that in your paper 3 practical, sometimes they will ask you to heat up a metal nitrate. So they will give you a piece of metal nitrate and then ask you to heat it up. Then what happens is that it will decompose to give you metal oxide plus NO2 gas plus O2 gas. So the NO2 gas is actually a brown gas. And then what happened is, in terms of QA, what you will do is you will test for this O2 gas. Okay, so metal nitrates is, I put it in is because number one, I think it's quite relevant for paper 4 practical. It's also something that is good to know. But if you don't really have the appetite for it, I need you to really remember just the first one, which is metal carbonate. So the metal carbonate, confirm must remember. The metal nitrate, if you can handle it, then please remember it as well. So that clears the first reaction that falls under metal compounds. I will now clear the last reaction. So the last reaction that you need to know is your R. So it's decomposition and what is R? Reduction. Okay. So the R here is reduction. Okay. So how does the reaction work? So first thing is, you must understand the underlying concept, the underlying logic. So the underlying logic is this: the more reactive the metal, the more stable the metal compound, and the less likely or the harder the compound will be reduced by a reducing agent. Now, if you have attended the lesson up to now, you will realize that actually this topic is quite related to your redox. So what happened is, if you really want to master this topic, you should go and revise on your redox as well, because usually redox, reactivity series, periodic table, as well as some of you who are doing electrochem, these 4 topics are very interrelated. Understand? So definitely you'll be tested a lot of redox inside reactivity series. Okay. Can I? Okay, so give me a minute. Let me just pull this down to here. So the final reaction we're going to talk about is reduction. Okay. So what happened is, the more reactive the metal, the more stable the metal compound, the less likely and the harder the compound will be reduced by a reducing agent. In this case here, you are being tested on 2 reducing agents, C and CO, that is one, and H2 gas, that's the second one. So we will examine these 2 reactions here. Okay, the first one is with C and CO. So for C and CO, quite simple. Basically, what happened is, the metal oxide will react with C and CO to form the metal. Now, you must understand what is the role of the C and the CO. The C and the CO is there to take away the oxygen. So when the C and the CO take away the oxygen, it will form CO2 gas. So what I observe is, number one, primarily a lot of people don't know that they form CO2 gas. So you must remember, when you use C and CO, it takes away the O, it will form CO2 gas. The second thing you need to remember is which metals can be reduced by C and CO. So primarily oxides of zinc all the way to gold can be reduced by C and CO. So in terms of the chart here, what happened is focus on carbon. Whatever that is below carbon will be able to be reduced by C and CO. Okay? Next, H2. So same thing. Number two, when you use the second reducing agent, which is your H2 gas, correct? So you take the metal oxide, you go and react it with H2 gas. The H2 gas is primarily there to take away the O. So you will end up forming the metal plus H2O, water. But this time around, take note, H2 is not a very good reducing agent. So H2 is a weaker reducing agent. So as a result, it cannot react with so much of the oxides. It only reacts with oxides of iron all the way to gold. So which means that in the chart itself, from iron, you go down. Okay. I'll show the chart again in a minute. Yeah. So for those of you who are trying to figure out this, so just remember, the second reaction is reduction, whereby you will try to reduce the compound with a reducing agent. You can use either C or CO as well as or H2. So C and CO, when it reduces the metal oxide, will give you metal and CO2 gas. Then whatever that's below carbon will be reduced by C and CO. Next, the second reducing agent is H2. So the H2 is there to take away the O from the metal oxide. It will form water. But it's a weaker reducing agent, so it cannot reduce so much. So one lesser than C and CO. So that means from iron all the way to gold. So primarily, if you really need a quick summary to remember which metals can react, which metal cannot react, focus on something like this. Okay? Now, if you see the four highlighted elements, C, I, M, and H. So how do you remember? Always remember these four elements. Just think of Cia at IMH. Because I think most of you are being driven mad by this topic as well. So I'll see all of you at the Institute of Mental Health. Okay, so just think of Cia at IMH. CIMH, okay? Okay, if not, then this is the overview of reactivity series itself. This is everything you need to know about reactivity series. Obviously, I didn't cover a few concepts, but I think you can go back and revise on it. So primarily, remember your rusting as well as your extraction of metals. So those two, I have deliberately leave it out because I think it's not very commonly tested. Okay. Now, how is this part going to be related to periodic table? Actually, quite simple. So what happened is, if you recall, in periodic table, you need to learn two groups, group 1 and group 17. For group 1, your two metals are already here. Correct? So whatever these two metals can do, meaning that it can react with steam, it can react with water, it can react with acid, that is applicable to your group 1 metals. The only thing you need to remember about group 1 metals is that its reactivity decreases down the group. The reactivity increases down the group. So that's how I will link it to periodic table. Periodic table primarily is just need to remember the reactivity series, the reactivity of group 1 metals, which is that it increases down the group, and then remember the reaction with water. Then you're done with group 1. Next, for group 17. Group 17 is more commonly tested, but the concept is almost the same as metals, because like metals, group 17 can also do the displacement reaction. So this is where I will link it up with group 17. So for group 17, you just need to remember the displacement reaction is almost exactly the same. A more reactive halogen displaces a less reactive halogen from its salt. So I can assure you that for your WA1, if you are tested on these two topics, the displacement reaction will definitely come out. It's just whether is it for metals or is it for halogens. But the concept is the same. So same thing, you just need to do your two checks and your two balances. So what are the two checks? The two check is you will be given a halogen molecule plus a salt, and the salt will contain the halide ion. So example, halogen molecule like Cl2, halide ion like Br minus. Okay? Now, what you need to remember is the reactivity of group 17. So group 17 is the opposite of group 1. The reactivity decreases. So which means that if you have F2, Cl2, Br2, I2, this is the most reactive and this is the least reactive. So if you look at this part here, your halogen molecule, Cl2, is more reactive. Your halide ion, Br minus, is less reactive. The two checks pass, this reaction will work. So what will happen? Same idea, the two balances it's the same thing. It's exactly the same thing. The more reactive halogen will go from molecule to ion. And the less reactive halogen will go from ion to molecule. So basically what you're going to expect is Cl2 is going to become Cl minus, Br minus is going to become Br2. Then you just balance the equation. So just need to remember, group 17 need to remember two things. Reactivity series, displacement reaction. The concept behind the displacement reaction of halogen is exactly the same as the displacement of metals. Okay? Next, group 1 just need to remember the reactivity and then just need to remember the reaction with water. So actually technically periodic table should not be a topic by itself because a lot of concepts is already being taught in metals in reactivity series. You can just gel these two topics together. Okay, with that, that is what I want to cover in terms of content. I think primarily, I hope this table can really help you to remember all the things you need to remember about the reactivity series. Okay, whatever I'm showing here lah. Okay, all the extra stuff that is written outside is just extra explanation. Oh, thanks. Okay, now I need to go through some exam questions. I think I will overrun but bear with me lah, okay? If I happen to overrun, I'll try to overrun less than 15 minutes. Okay, so the first thing I want you guys to take note of is this question here. So we will do two questions, one on metals, one on reactivity series, and one on periodic table. Okay, so primarily, I think what I want to really get you guys to really focus on is if you look at page 3 of this question here, okay, which is question 7 of the reactivity series. So after your reactivity series notes, there's the worksheet. Don't worry about the answers. Later, I will distribute the answer to you all, okay? So I just want to pick a few questions to really discuss. The first question I really want to discuss is question 7 here, okay? So you look under the reactivity series worksheet and then go and focus on question 7. Okay. Thanks. Okay, so question 7. Okay, so this question is a modified question, but it was modified from an O-level TYS question. So this type of question has definitely come out for O-levels before. Okay, so if you see, this table is very typical of what a displacement reaction is. And if you read the question, obviously, if you see, they have talked about the displacement reaction, right? Now, so what happened is some students, they cannot read the table. My mission today is to teach you how to read the table. Very easy. Number 1, if there's a reaction, give a tick. If there's no reaction, give a cross. So for example, if you look at each box, first one, copper. The solution remains colorless, no reaction, give a cross. Solution remains pink, no reaction, give a cross. Solution remains green, no reaction, give a cross. So all those that has no reaction, you give a cross. Okay? Whichever that has a reaction, so for example like this, brown solid formed in a colorless solution is a reaction, give a tick. So during your exam, if you see a table, a question involving displacement reaction, what you need to do is give ticks and give crosses. If there's a reaction, tick it. If there's no reaction, give a cross. Then after that, I'll teach you how to deduce the reactivity. Okay, so obviously if you see the first question, they want you to arrange the 4 metals in order of reactivity. Now, how do you do it? Very simple, do math. So if there is a reaction, or rather if the metal is the most reactive, you will get all ticks, no crosses. So for example, if you see, cesium got 1, 2, 3, 3 ticks. Copper got 0 ticks. Cobalt got 1 tick. Chromium got 2 ticks. The more ticks you have, the more reactive you are. So this is the most reactive. This is the least reactive. So order of increasing reactivity. So from least reactive to most reactive. So from 0 ticks copper, that's the least reactive. Because if you think about it, it technically cannot displace any of this solution. Followed by cobalt with 1 tick. Because technically, if you think about it, it can only displace copper. Cannot displace cesium, cannot displace chromium. Then is 2 ticks, chromium. So chromium can displace copper, can displace cobalt. Then finally is cesium. Cesium can displace all the metals. So you just need to remember, don't need to keep trying to figure out what is happening. Just go and tick and cross and count the number of ticks. So this is like the shortcut. Okay? But obviously, I teach you shortcut. I also want you to still understand what is happening. So basically, if you see, cesium is the most reactive metal. It is able to displace all the other metals from their salt. Copper, being the least reactive metal, will not be able to displace any of the metal from their salt. So we figure out who is the most reactive, who is the least reactive. Then we just need to compare cobalt and chromium. So if you see chromium versus cobalt, chromium can displace cobalt. So chromium is more reactive, cobalt is less reactive. So that is how you do question A. The shortcut is to just count the number of ticks. The long way is to really process the reaction. Okay, next. For this DYS question, right, what happened is question B. Everyone died in question B. Because what happened was they saw question B. What is the color of copper 2 sulfate, cobalt 2 sulfate, and chromium 3 sulfate? Hey, I never learned cobalt 2 sulfate and chromium 3 sulfate. So how would I know the color? Yeah, you must remember this. O levels is not torturous. Okay. Preparing for O levels is torturous. But the exam question is always going to provide you some clues to the answer. Understand? So it's just whether you can really see the clue or you cannot see. Technically, if you think about it, copper cannot displace any of the metals from its salt. So which means that the salt will remain as it is. So if you think about it, what does this tell you? That means cesium sulfate is actually colorless because there's no reaction. So cesium sulfate remains as cesium sulfate. Cobalt 3 sulfate is pink in color. Why? Because there's no reaction. So cobalt 3 sulfate is cobalt 2 sulfate is still cobalt 2 sulfate. Lastly, chromium 3 sulfate, if you think about it, copper cannot displace chromium. So chromium 3 sulfate remains as chromium 3 sulfate. So it will remain as green. So technically, you already have your two answers. Cobalt is pink. Cobalt 2 sulfate is pink. Chromium 3 sulfate is green. Then how about copper 2? So unfortunately, copper 2 is something that you are going to come across a lot. So it is expected knowledge. So can anyone tell me what is the color of copper 2 sulfate? Okay, never mind. I answer my own question. So copper 2 sulfate is actually blue in color. Thanks. Unfortunately, I am not at the Coven Center, so I cannot bring out my chemicals and show you. But copper 2 sulfate is blue in color. I believe all of you will come across copper 2 sulfate in your practical lab itself. Maybe what I can do is I'll just show you pictures of it, okay? So copper 2 sulfate solution. Yeah, so this is like the blue you are expected to see. Okay. This is technically a very diluted blue lah. So if you do a displacement reaction, eventually you will get something like this. Okay. Wait, Hey, nice. Copper growing copper crystals. Okay, so copper 2 sulfate crystals is the best to grow. Like, it's very easy. You don't need to wait until like months for the crystal to grow. Within days, the crystal will grow already. Okay. C. Write an ionic equation for the reaction between chromium and cobalt 2 sulfate. So chromium will react with cobalt 2 sulfate. Okay, first thing first, how to write ionic equation. So some of you cannot remember how to write ionic equation. Very simple, we start off with a chemical equation. So usually what happens is I'll tell my students, for chemical equation, right, if the question say need to write state symbol, then you write. If the question don't need you to write state symbol, don't write. Okay. But more importantly, what I want you to focus on is because you are dealing with an ionic equation, right? So for ionic equation, your chemical equation, you need to write state symbol first. So chromium solid plus cobalt 2 sulfate equals. Now, based on displacement reaction, you will learn chromium is more reactive than cobalt. So chromium can displace cobalt from its salt, correct? So this is more reactive. This is less reactive. This reaction will work. So chromium will turn from a metal into an ion. But some of you are probably wondering, oh, so what ion will it turn into? So remember, the question will always give you the clue. So the question told you that it forms chromium 3 sulfate. So basically that is the ion it becomes. So from chromium metal, it will give you chromium 3 plus. Then you combine it with your sulfate ion, SO4 2 minus. So you will form Cr2 SO4 3. Because you need to balance the charges, remember? So chromium 3 plus here is a +6 charge. Sulfate ions, this is a -6 charge. So it will balance out. Then plus the cobalt metal. Take note, this is not the answer because this is the chemical equation only. Then from the chemical equation, how to make it into the ionic equation. So some of you still not very clear. You know you need to keep something, you need to break something. But what do you need to keep and what do you need to break? So remember this, what do you need to keep? Anything in solid, liquid, or gases, keep them because you will need them. Then next thing is aqueous, we will break it up. But some of you like to break up every aqueous thing that you see. There are certain aqueous things that you cannot break. For example, Cl2, a covalent molecule. You cannot break it up, so you keep it. So aqueous covalent, you keep. So what do you break? Very simple. Aqueous ionic, you can break. Acids, you can break. Alkalines, you can break. So the 3 A's are usually what we will break up. The rest, we will keep them as it is. So if you think about it, chromium solid, keep. Cobalt sulfate, I will break A. But before that, stop first. I need to balance my equation. Forget to balance. So here put a 3. Here put a 2. Then here put a 3. Okay, then I can start to break them up. So 2 chromium solid, keep. 3 cobalt, 2 sulfate, break. So I break. Next. Chromium 3 sulfate, I break. So 2 Cr3 plus, 3 SO4 2 minus. Then my cobalt metal, heat. Cancel out the sulfate. This is my final equation. Okay? Okay. Next, for those of you who are tested on rate of reaction, listen to me. The next question. Before we do the next question, I want to do D. Okay, because D is also something that is a little bit tricky. So the student observed fizzing when calcium is added to separate samples of each of the 4 solutions. Now, when you see the word fizzing, you will think of gas. Correct? So you think that there's a gas liberated. But then you think back and you look at what we have done here. This is a displacement reaction. And you think back of what you learned about displacement just now. Does displacement give you gases? The answer is no. So a displacement reaction cannot give you a gas. correct? So where did this gas come from if it was not a displacement reaction? So let's look back at the summary that we did. So based on what we know, a displacement reaction technically will not give you any gas, correct? It's just not possible because it's just metals changing oxidation state. So there's no gas that is coming out. But what happened is, if the metal was reactive enough, for example, like calcium, it can react with water, and we know that an aqueous solution has water. Am I correct? Because an aqueous solution, the solvent is water. So if you think carefully, technically what that question is trying to tell you is, when you add very reactive metal, you can expect two reactions. Okay, so let me flip back to that question. So when you add in, you think back of calcium. Calcium is a very reactive metal. So when you have very reactive metal, for example, like your four musketeers, potassium, sodium, calcium, and magnesium, correct? These four are very reactive metal. They will not only do displacement when they are added to the salt, but they will do metal plus water as well. And metal plus water will give you metal hydroxide plus H2 gas. So the fizzing that you see, this gas liberated is actually H2 gas. And it's the result of calcium reacting with the aqueous solvent. So basically what you need to write is very simple. H2 gas is formed when calcium reacted with water in the salt solution, causing effervescence of H2 gas. Okay? Okay. For those of you who are doing rate of reaction, I'm going to spend the next few minutes talking about rate of reaction first. Then we'll come and look at the final question for today, which is this question here. Now, I think all of you, those who are doing rate of reaction, right? I don't think y'all don't know how to memorize the 5 factors. So obviously when it comes to rate of reaction, the 5 factors that affect rate are very important. So you must go and remember the how to phrase your answer, all the exact wording and everything. I don't really want to focus on that because that is more of like memory work, regurgitation work. What I want to focus on is the graph. So those of you who did this topic, you should know that obviously what they will do is they will give you a graph, then they will ask you to draw a new graph, correct? So what happened is, when you are drawing this graph, you need to watch out for 2 things. What are the 2 things? Number 1, the gradient. And we are looking at the gradient, take note, you are looking at the initial gradient. So I don't really care about what happened afterwards. I care more about what you see here. Understand? So you must take care of your initial gradient. Next, number 2 is the height. Sometimes they will plateau off at the same height. Sometimes the height that plateau off will be twice. Sometimes the height that plateau off is half. So when do you draw what kind of graph? Okay, very simple. You just need to remember this. The 5 factors are temperature, pressure, catalyst, as well as surface area or particle size. Now, if you think about it, the height is actually the yield of the product. And then the gradient is obviously the rate. So the yield of your product is affected by the yield of your reagent, correct? So for example, if I use more reagent, I will get more product. If I use less reagent, I will get less product, correct? But what happened is that these four factors here, temperature, pressure, catalyst, surface area, they don't really affect the yield, the amount of reagent you use, correct? So they don't change the amount of reagent you use, therefore they don't change the yield. So for this four factor, you just need to remember, you will change the gradient will change, but the height remains. That means you will always plateau off at the same height, but your gradient will change. If the reaction makes it faster, then you will draw a faster grade, a steeper gradient. Then you plateau off at the same height. If it causes your reaction to be slower, then you draw a gentler gradient, but still plateau off at the same height. Correct? Because the height, the yield of your product does not change. So what changes the yield of your product? Obviously, it is this factor called concentration. But concentration, you must also think back of what you learned in stoichio. If you have an excess reagent, it doesn't change your yield, correct? What changes the yield of your product is the concentration of your limiting reagent. So which means that for those of you who are doing pure, all of you are doing pure science, pure chem. So technically what happened is that if your concentration change, you should go and determine the limiting reagent first. Because the limiting reagent will cause not only the gradient to change, but the height to change as well. So take note, this 5 factor here will only change the gradient. It will not change the height. Only by changing the concentration of your limiting reagent, then your height and your gradient will both change together. So this is what I want to say about the graph, because I think technically the graph will be the one that is the commonly tested question. Okay, coming back to this. So how is rate of reaction going to be linked to thermal decomposition? Now, if you think about the logic that I shared with you earlier, more reactive metal, more stable compound, harder to decompose, correct? What happened is that if the metal carbonate was super stable, it's going to take a very long time to decompose and produce the same, or rather what happened is that if the metal is very reactive, the carbonate is going to be very stable. So within the same duration of time, it's not going to produce a lot of gas because it doesn't break down to give CO2. Whereas if your metal was very not reactive, for example, like copper carbonate, then the compound is going to be very unstable. So when you heat it up, it immediately breaks down. It's going to give you a lot of CO2 gas. So if you look back at these 4 substances here, and you recall back about the reactivity of metals that you arrange in A, you're going to see that cesium, being the most reactive metal, will give you the most stable compound. So it's going to be very hard to break it down, which means that if you heat it up for 12 minutes, it will not break down. It doesn't give you any gas at all. Whereas for copper, this is the least reactive metal out of the 4. The compound it forms is going to be very unstable. So it will break down very quickly. It gives a lot of CO2. So basically, if you think about it, most reactive metal, this is number one. Chromium, this is the second most reactive metal, followed by cobalt, the third most reactive metal, and then finally is copper, the fourth most reactive metal. Okay, so how do you explain this? So the idea is this. I'm going to finish that, just bear me. The more reactive the metal, the more stable its carbonate is. So if the carbonate is very stable, it's not going to be able to break down very easily. So it's not going to break down very easily. It will give you the least volume of gas. Okay, now, if you give me an answer like this, you technically will only get 1 mark. Why? So I just want to share with you guys this exam kind of thing, okay? Or exam questioning. Now, if you see the question asking you to use the student result, use the data provided, use the table that is given to you, you really have to make reference to the table, make reference to the result. So if you talk about things in very general form, like something like this, you're not going to get the full marks. In fact, some teachers will not give you any marks because you never make reference to the result that you see here. So how do I make reference to the result that I see? So basically you tell me from the graph, cesium as the most reactive metal forms a very stable carbonate that does not decompose. So because it does not decompose, that's why you see the CO2 gas that you collect is technically 0. While copper as the least reactive metal forms the least stable carbonate that decomposes rapidly to form, if you just write to form CO2 gas, also no, because make reference to the table. So if you look at the table here, you form 45 cm cube of gas. So decompose rapidly to form 45 cm cube of CO2 gas. I need to see tables, I need to see values. Okay? Okay, finally, the last question before we call it a day. Okay, so on graph 7.1, right, can you sketch the curve when 2.5 grams of copper 2 carbonate is heated strongly? Indicate clearly the volume of CO2 gas you form. So technically, if you recall, this equation was what? Copper carbonate will decompose to give you CaO plus CO2, correct? You use 5 grams of this and you ended up forming 45. Copper 2 carbonate in this case is your limiting reagent or is your only reagent. So if you cut the volume, if you cut the amount by half, which is 2.50, then technically the maximum volume of CO2 gas it can produce for you is also cut by half. So it's 22.5. So what happened is 22.5 is around here lah. Next thing is, if you use lesser solid, there is lesser number of moles, so the reaction will be slower. So your graph will look something like this. So it's a slower reaction because there's lesser moles, and also the height will be lower because you are using lesser gas, lesser of the limiting reagent. Okay, everyone okay now? All good? Anyone don't understand anything from this question? Okay, I know what are you all waiting for. So teacher can give me the answer to the rest of the worksheet. Yes, I can. Give me a minute. Okay. First thing first, anyone have any question with question number 7? If you have, quickly sound off. If not, what I'm going to ask you to do is, there's another question that I do want to go through, but I'm running out of time, so I'm just going to flag it out. I think y'all can go and take a look at this. This has something to do with periodic table. Can you please go and take note of this question? Technically, it's just part 2. This question here. So go and focus on B part 2 because B part 2 is quite important. It's also a TYS question. Yeah. Okay, now, if let's say technically you look at B part 2 and you don't understand what is happening and you need some help, you can find me at my Telegram handle. This is my Telegram handle. Okay, then you just message me, say, can explain to me this question or not. Okay. Okay, so now I'll just do a quick wrap up. Yeah, for everyone. Okay, so I'll do a quick wrap up, and then after that I will tell you guys where to find the answer. Okay. Okay, so first thing first, yeah, obviously if you enjoyed the session, and you don't mind leaving a review, please leave a Google review for me. Yeah, and then next thing is, if you are looking at finding me for tuition, technically I only teach one class lah. So I only teach at Hoven on Sundays, from 10 to 12. Okay. But alternatively, if you are looking at other time slots, this is primarily the group tuition for Pure Chem. Yeah. So first thing first, maybe if you want to leave a review, just scan the QR code. It will disappear in 5 seconds. 5, 4, 3, 2, 1. Next, if you are looking for group tuitions, you can scan this QR code. I'm just going to advertise Pure Chem lah because I teach Pure Chem. The other subjects all can be found inside the website that this QR code is going to bring you to. Okay. Last but not least, the answers. Okay, so give me a minute. I'm going to upload the answers. Technically, it's the same folder that you see. It's just that now I'm going to add in the answers. Okay, give me 2 seconds. So, so here you will be able to find the answers to the worksheets themselves. Let me just show you guys. Yep, so I have provided everyone with the answers to the worksheets. Take note, if you have any questions with regards to the worksheet, you need some explanation, you can always find me at my Telegram handle, ASHCYH. Okay, I just put it on the chat itself. Wait, where's everyone? Wait. Sorry. Ah. Yes, I will. Give me a minute. Okay, so you should be able to find this answer sheet inside. It has all the answers to the worksheet. Okay, let me share the QR code again. Sorry. So, yep, you should be able to find the answers to the revision worksheets. Everyone can see the revision worksheet, right? Who cannot see, please sound off. Yeah. Is it there? Cannot see. Wait, I share the Google Drive link. It should be inside. You refresh again. Wait. Okay, it is all. Wait, I put it inside the group chat. So this is the Google Drive link with the notes for today as well as the answer sheet. Okay, now, finally, if you have any questions you want to ask with regards to your WA1, please do stay back. If not, sorry to delay you guys. I think some of you are rushing off for dinner. So, if you need to rush off, just go and rush off. Yeah, then I'll see you guys around. Bye. I will. So I'll go through question 2 in the periodic table worksheet. Okay, question 2 as in MCQ question 2, right? Okay, can. So which statement best describe element X in group 17 of the periodic table? X burns in oxygen to form an amphoteric oxide. So if you think about it, amphoteric oxides, based on what you remember, there's only 3, correct? Which is aluminium oxide, lead-2 oxide, ZAP, and zinc oxide, correct? It doesn't involve anything that has to do with group 17, correct? So option A is out. More specifically, what I want to stress on is X is a non-metal because X is from group 17. So it's a non-metal. When it burns in oxygen gas, you most likely will get an acidic or a neutral oxide. You rarely will get an amphoteric oxide because an amphoteric oxide primarily is formed from a metal, correct? So it's a metallic oxide. So usually that's why A option out. Okay, next. So element X reacts vigorously with water to form a acidic oxide. Technically, that makes sense, lah, right? So D may be the answer, but let's wait a minute first. No, wait. Element X, you mean, so if you think about it, Cl2 react with water to form a acidic oxide? Did you learn, I think, okay, wait. Sorry, one by one. I clear D first, okay? Then I'll answer Terence. Element X reacts with water to form an acidic oxide. So based on what you know, halogens, correct, do not react with water. You don't learn a reaction like this. So D don't make sense because this is not inside your syllabus. In fact, this is not a possible reaction, lah. So D is out. Because you don't learn it. There's no such thing. Next, so we are down to B and C. Correct? Mm. Now, if you look at this formula here, correct? What you will be thinking of is x7 plus, x7 minus, and then h plus. That is also something that seems very weird, correct? But I want to talk about option B in a while. So what happened is, never mind, I'll talk about it now. So element X forms a hydride. Hydride is basically H minus. So if you think about it, if it was H minus, that means X will be 7 plus. H minus is technically quite ridiculous for an atom to be able to lose all its electrons to form 7 plus. Correct? That one is a very highly charged metal, highly charged atom. So if you think about it, you want to lose 7 electrons, you need to absorb a lot of energy. It will make the element very unstable. So B kind of don't make sense. C will make sense because of this. We know that when X2 undergo redox, it tends to form X minus. So if you think about it, this is like going from 0 to -1. This is a reduction reaction. So what kind of substances do reduction? Oxidizing agents. So for those of you who do not know, actually your X2 is a very good oxidizing agent. So that is the reason why it can oxidize the sulfide ions to sulfate ions. So this sentence makes the most sense. Okay. You take some time and absorb. Let me talk to Terrence. Terrence, is there a way to get the lesson recording? If I'm not wrong, they are going to post it on YouTube. So you just watch out for the YouTube recording. They are going to post it on YouTube lah. Yeah, if I'm not wrong. So you just find the OVERMUGGED YouTube channel. They should post it within about 1 to 2 weeks time. Okay. Sid, any problems not? Oh, okay. With question 2. Okay, good. Just take note, hydride is actually H minus. Hydrogen ion is H plus. So this thing, hydride, if you see the word hydride, take note, it's a hydride ion. So for some of you who don't really know what is this thing called a hydride ion, I just share with you all lah. Okay, hydrogen ion basically is whereby your hydrogen got 1 electron, it loses the electron, so it forms H plus. So H plus is called hydrogen ion. Hydride ion is H minus. So basically your hydrogen got 1 electron, right? It accepted another electron to form a H minus ion. So this thing doesn't violate bonding rules is because your first shell has a duplex structure. So that's why there's such thing called a hydride ion. So the electron that it gained all came from the element X. But for element X to lose 7 electrons and to form a 7 plus, that is too much for the ion to bear. So that's why technically to me, X7 plus, this thing is super unstable. So that's why sentence B don't make sense. Then sentence D is technically there's no such reaction. Okay, anyone got any more questions? If you want to ask me other topics, that's also okay. Anyway, I'm just here to help you with your WA1. So if you are looking for other topics, just throw the topics at me. Okay, if not, then maybe what I'll do is I will help you all with this question. Okay, so basically what happened is, if you recall, this is displacement of halogen. More reactive halogen will displace a less reactive halogen from its salt. For solution M, basically what happened is Cl2 will react with I minus. Based on what we know, Cl2 is more reactive, I minus is less reactive. So the Cl2 will be able to displace the I minus from its salt. You form Cl minus plus I2. Correct? So the balancing of the equation will look like this. So technically, why is it brown in color? Is because I2 in solution is brown. So you must remember I2, this substances very irritating. When I2 is a solid, it is black, purplish black. When I2 is a gas, it is purple. When I2 is in aqueous state, it is brown. So that's why the solution is brown. Next, for solution N, if you see, you take I2 and you react it with Cl minus. Your I2, which is your halogen, is less reactive. Your Cl minus, which is your ion, is more reactive. So the halogen cannot displace the ion. So there is no reaction here. So because there's no reaction, you are left with the I2. And the I2, once again, because it's aqueous I2, is brown. So that's why both the solution is brown. Okay? Okay, any more questions? Anyone? Oh, I can. Because if you think about it, based on what you know about displacement reactions, is that a more reactive halogen displaces a less reactive halogen from its salt. So first thing is we need to establish who is more reactive, who is less reactive. So if you recall your periodic table, F2, Cl2, Br2, I2, reactivity decreases down the group. So F2 is the most reactive and I2 is the least reactive. So if you compare Cl-2 and I2, chlorine is a more reactive element, it's a more reactive halogen, and I2 is a less reactive halogen. So remember what I told you about your two checks, right? So you will be given a halogen molecule and you will be given a halide ion. Your halogen molecule must be more reactive. Your halide ion must be less reactive. But in this case here, your halide ion is more reactive and your halogen molecule is less reactive. So the I cannot kick out the Cl. So that's why there's no reaction. Because I being less reactive, then Cl cannot kick Cl out. Okay, great. Take note, displacement reaction is the same one. Metals, halogen, the idea is the same. It's just for two different sets of groups. But if you understand the concept, then you just need to apply to both the metals and the halogens. Yeah. And then just pray that your teacher just bomb these two, because bomb the two displacement reaction, then you confirm guarantee chop will get high marks. If you understand the displacement reaction. Okay, anyone, come. What other questions? Actually, B also quite interesting. If you all look at B, So B technically is displacement reaction. It's just that, okay lah, maybe I explain a little bit about B. Okay, so what happened is you bubble chlorine gas inside, right? So in this region here, what you see is Cl2. Oh, okay, okay. What are the colors of the flame of group 1 sparks? Do you need to remember that? Oh yes, you may need to remember, but actually I don't think it's very important. But I'll explain this part first, okay? So Cl2 gas will react with the bromide ions. So once again, we are doing displacement reaction. If you recall, your halogen molecule must be more reactive, your halide ion must be less reactive. Cl is more reactive than Br, so this is more reactive. This is less reactive. There will be a reaction. So the reaction will give you its Cl minus plus Br2. So what happened is, because of the displacement reaction here, your chlorine will displace the bromide ion. So your region P, you will start to see Br2 gas. So Br2 gas is a reddish brown gas. So that's why what you will observe is a reddish brown. A reddish brown gas lah. Why is because chlorine being more reactive than bromine will displace the bromide ions from NaBr to form Br2 loss. So chlorine So that's why you will start to see Br2 coming out. Then what happened is in this region here, I put in green now. In this region here, what you will observe is the Br2 is now going to approach the sodium iodide. So Br2 will react with iodide ions. So once again, you do your check. If you see, halogen molecule must be more reactive, halide ion must be less reactive. Br is indeed more reactive than I. So this is more reactive. This is less reactive. Once again, a second displacement reaction will happen. It will give you Br minus and I2. So iodine, because of the heating, it sublimes. You will see a purplish gas in region Q. Okay, reason exactly the same as the one on the top. It's just that now the elements involved are different. So to save me, I will just change. So bromine being more reactive than iodine will displace I minus from NaI to form I2. Then what happened in region R? So you must recall that, wait, so cause Cl is more reactive than Br, then they just react and swap oxidation state. Yes, correct. Yeah. Yeah, correct, Chloe. But for metals, when they don't really swap oxidation state lah, because the oxidation state may be not exactly always +2 and +2 and +2. So they will still swap. It's just that sometimes it's +2, +3, then you need to balance it. Okay, for region R, so what happened is the I2, you all must remember, because this is in Sec 3 work. So in Sec 3, the very first few chapters, you learn about substance that can sublime, correct? So what substance can sublime? Obviously, if you recall, your CO2 gas can sublime, I2 can sublime, ammonium chloride can sublime. So basically what happened is Q, the region very hot, but once it reaches R, the region cool down, the solid I2 will sublime, or not sublime, is to do the opposite, which is to do deposition to form the solid I2. So in region R, what happened is I2 gas undergoes deposition. This one you all should learn in your kinetic particle theory. The opposite of sublimation. So this is the opposite of sublimation, which is deposition. So the I2 gas undergoes deposition to form solid I2. So what you're going to expect to see is a purple-black solid. Okay? So this is another displacement reaction again. Because technically they can only test you displacement reaction for group 17. So you must really master your displacement reaction. Okay. Now, let me explain. What are the colors of the flame of group 1 sparks? Technically, you only need to remember two. Potassium is lilac. Never mind. Just refer you to the notes. Great. The notes never say. Okay, never mind. Just remember. Lithium, no color. Sodium is yellow. We are talking about reaction with water, right? So when sodium reacts with water, you will see yellow flame. Potassium react with water, you will see lilac flame. Rubidium, cesium, francium, don't need to talk about it because the moment the rubidium, cesium, and francium touch the water, your trout will explode. So you will not see any color. Then lithium, the color too light, you cannot see. So it's just yellow and lilac. Let me double confirm. Yes, correct. So I hope that answers one of your, whoever asked the group 1 sparks. Wait, sorry. Can I ask, your group 1 sparks is, I need to clarify again. Group 1, when you talk about group 1 sparks, is the metal add to the water, right? Not you take the metal and you burn it inside the flame, right? So it's which one? Burn in fire or add to water? Oh, add to water, yes. Then it's just yellow and lilac. Burn in fire, don't need to remember, because it's not tested. How come iodine undergoes deposition in region R? Because region R, you see, is very far away from the heat already. So if you go back to that graph, do you see region R no more heating? This is region R, right? There's no more heating, correct? So no more heat means the thing can sublime back or can undergo deposition. That means it can do the opposite of sublimation. So you know what is sublimation, right? That means it goes from solid to gas. So the opposite of sublimation is from gas, it will straight away bypass the liquid state and become a solid. Because that region is no longer hot. So that's why. Chloe, okay not? Okay. Anyone has any more questions? If not, then technically, if you ask me, periodic table, actually, I wanted to go through this question. Then actually, technically, the rest here quite simple already. Yeah. Question D is more for those who are doing periodic table, those who are doing rate of reaction. So if you recall what a catalyst is it will be consumed in one of the reaction and regenerated at the end. So if you can see, it reacted in the first reaction, then it came out in the second reaction. So the idea is basically how you want to explain it's a catalyst. You just say consume in first step, regenerated, and please use the word regenerated in the second step. Then you will get the 1 mark. Then why CFC is very harmful? This one is more for those who are learning air. Basically, if you think about it, one Cl atom can destroy 2 ozone, and then it regenerated. So the cycle will just keep happening, lor. Destroy 2 ozone, come back again. Then destroy another 2 ozone. Destroy another 2 ozone. So every cycle, it can destroy 2 ozone. Compoundedly, eventually your ozone layer will be gone. Okay. Okay, if anyone don't have any more question, I think I'm going to end the session here. Okay, Ken? Yeah. If not, then yes, all the best to everyone for your WA1. Remember, at the end of the day, at the end of this session, what I really want you to remember is displacement reaction. So I thought that it remains chemically unchanged. So how can it be regenerated? Yeah, it regenerated. That's why it's chemically unchanged. Right? It didn't change chemically at the end. So when we talk about a catalyst being chemically unchanged, it means that when you start the reaction, it is Cl atoms. At the end of the reaction, it is also Cl atoms. So if you think about it, at the start of the reaction, the Cl got consumed, and then at the end, it came back out. So you still find the Cl. It didn't change chemically, but can it change within the reaction? Yes. So when it regenerated, there's like, it appeared again. Yeah. So we treat it as overall, it didn't change. Yeah. So more importantly is what I need you to take away from today's session is displacement reaction. Very important. Okay. Every year displacement reaction is tested. So you must be very good with your displacement reaction. And then more importantly, I think all the best to everyone for your WA1. Go score that A1. Okay. Okay, if not, then I think I'll end the session here. Anyone still have any more questions can more or less type the chat. Yeah. Oh, thanks. All the best to everyone. Yeah. If you enjoyed the session, if you want to leave a Google review, please do lah. Okay. You may have a chance to get the curated notes. I shall post that page again. Yeah, so yeah, the top review, you will get the $40 worth of curated notes. Yeah. Thanks. Bye. Bye, Chloe. Bye, Tiffany. I hope everyone enjoyed the session. Yeah. Bye-bye. Bye. Hey, thanks YW for being so proactive in the class. Thank you. Thank you. Bye-bye. Julie, you have any more questions?